Oh boy, look at this equation here, this function here. It says the number of bald eagles in a state during the winters from 96 to 2002 can be modeled by this quartic. Quartic means fourth degree, and there it is, the fourth degree, by this quartic function. Oh boy, look at this. Now, where x is the number of years since 1996. So x in here, this x, all the x's, this is just a counter for the number of years since 1996. So when I see that x, I'm thinking time. That's the number of years since 1996. And f of x itself is the number of bald eagles. So it says the number of bald eagles depends on the number of years since 1996. So when you read this, read it like this. So when you read this, at this part right here, just think of that. All right, it's telling you that something depends on this. So this, the f, depends on this. And f, in this case, is the number of bald eagles, and it depends on the number of years from 1996. And how do we get that? How do we make the conversion? We do all of this. So, you know, the way I like to do things is this. Here's our input values, and these are x's. These are the number of years since 1996. And then what we're going to have in here are the computing instructions. Now, the computing instructions here, that's all of this. All right, I'm not going to try to write it, but that's this. There's this big set of computing instructions, right? That big, long expression. That's our computing instructions. And what we get out, those are our output values. All right, these are the outputs. Now, the input, all right, this is the f of x over here. These are f of x's. So what we have over here, the number of years since 1996, and this is the number of bald eagles. So here's what we want to know. Find the number of bald eagles in the state in the winter of 2001. So how about this? In 2001, we are, all right, how about 2001 minus 1996? That's equal to 5 years from 1996. So x is equal to 5. So what we need to do now is just put 5 into x, f of 5, and everywhere we see an x, we're going to put a 5. So let me get some room here. So let's get our calculators going. So here's what we're going to have. We're going to have f of 5 is equal to, now, we're going to put in negative 3.435 times 5 to the 4th plus 35.456 times 5 to the 3rd minus 97.279 times 5 squared plus 41.506 times 5 plus 176.342. Right, that's what we're going to put in on our calculator. We're going to put in this part right here. So put that in on your calculator and press enter and see what you get. Now when you get a number, what you're going to do is you're going to round it to the nearest whole number, right? We're counting the number of eagles. You can't have a fraction, so just round it to the nearest whole number. So when I computed this, I got 236.68, and if I round it up, right, I'm going to get, here's what I get. I get f of 5 is this. So f of 5 is 237. So the question is to do this. Find the number of bald eagles in the state. Well, I'm going to say in 2001, there were 237 bald eagles in the state. Now, you know this is quite a computation to make. So how about if you try Wolfram Alpha? So in Wolfram Alpha, I said evaluate, and then I put in the function. I use the x's, put in the function just as it was, and, well, not as it was. I guess I missed it a little bit over here. But I said when x equals 5. So I computed, I got 236.68 when I did this. Now, when P dollars are invested at an interest rate of R, so you invest P dollars at this interest rate, R, and you compound it annually for T years, the investment grows to a number of dollars where we have this. A is equal to P. All right, so this is the amount. This is the amount that it grows to. That's equal to the principal. That's how much you put in, times this quantity, 1 plus the interest rate raised to the number of years that you keep it in. And now we are told that Trevor's parents deposit $7,900 into a savings account. All right, so here's what we know. P is equal to $7,900. That's the principal. That's the amount that you invest when Trevor is 16 years old. Now, the principal plus interest is to be used for a truck when Trevor is 18 years old. All right, so how many years is this? This is 2 years, right? From 16 to 18. Find the interest rate. So what we want to do is we want to find R if 7,900 goes to 9039.75 in 2 years. So let's put these numbers in. So the amount is the amount, all right, this is principal right here. That's the amount to which it grows. So we're going to have this. We will have 9039.75 is equal to 7,900 times 1 plus R raised to the 2. And we're trying to find R, right? Find this. So how about first up, we divide by the 7,900. So how about 9039.75 divided by 7,900? This is equal to 1 plus R squared. Now, I'm not going to do this. Just leave this just as it is. We'll have the calculator do it all at the end. But you can see we have something squared. And this is what we did in the last section, is that we solved quadratic equations, a radical equation. We're going to take square root of both sides. So let's do this. We'll have the square root of 9039.75 over 7,900 is equal to the square root of 1 plus R squared. Now, this will give us the square root of this number, 9039.75 over 7,900. This is equal to, on the right side now, the square root of the square gives us the absolute value of 1 plus R. But now I know this has to be positive, right? This has to be a positive number. So the absolute value of a positive number is that number itself. So I can write this. The square root of 9039.75 divided by 7,900 is equal to 1 plus R. And then if I subtract the 1, I'm going to get this. I'll do it on the left side. R is equal to this square root, 9039.75 divided by 7,900, all that minus 1. Now, Wolfram Alpha or calculator. If you use your calculator, here's how you're going to do this. You're going to press the second key and then the x squared key. Right on top of x squared is the square root. So you'll get this. You'll get square root, and then you're going to put in 9039.75 divided by 7,900. And on my TI calculator, as I put that in, this radical goes all the way to the end. Now I have to get that radical off, so press the right arrow button. So I'm just going to press that right arrow button. That'll get me out of there. And then minus 1 and enter. And I came out with this, I came out with 0.0697 dot dot dot. Now, here's what we're looking for, right? We're looking for R, all right? So R, here it is up here. Let me circle it. Here's R. Okay, so this number here is R. Now, this is a percentage rate. So if it's a percentage rate, it's going to be, all right, 6.97%, or we could just round that off to 7%. So apparently, if you find a bank that'll give you 7% interest, you put in $7,900 for 2 years. At the end of 2 years, you will have this amount here. Where is it? The $9,039. All right, for this scatter plot, determine which of the following types of functions might be used to model the data. We'll look at this data here. This looks to me like it's going to be a parabola, which is an x squared, and it opens up. So I think it's going to be like ax squared plus some other stuff, and the a is going to be a positive number because it opens up. So which one of these is going to work? This says it's quadratic, yeah. A is greater than 0. I think that's what we want. Look at this one. This says it's quadratic, but a is less than 0. That means a is negative. All right, so this one here, a is positive. This one here, a is negative. So it's not this one. It's certainly not linear. It's not a straight line. A polynomial, not linear or quadratic. Well, I don't think that's it, because it sure looks quadratic to me. It sure looks like a parabola. And a parabola is quadratic. So I'm going to claim it's this one right here. Now, for this scatter plot here, which of the following types of functions might be used to model the data? Well, this sure looks like a straight line to me. And it's a straight line that, as I go left to right, falls. So I'm thinking it's a straight line that has negative slope. So let's see what we have over here. First one is linear, mx plus b. Yeah, it's not quadratic. Quadratics look like this. Or like the negative looks like this. Okay, it's polynomial, not linear, quadratic. This sure looks like a straight line to me. I'm going with this one right here. This problem has a lot of steps entered on the calculator, so we'll just do it together in class.